Hello students, in this lecture we are going to learn practical number 7, estimation of soil loss, that is USLE. We start today with the soil loss estimation, and we covered is the most widely accepted method for estimating the average annual soil loss, which is referred to as universal soil loss equation, very popularly known as USLE. So USLE is very popular component of soil and water conservation, and as it says, it is the most widely accepted method. Important thing to note here, that is used for estimating the average annual soil loss, that in long term soil loss it gives. It means that for single event this method cannot be used for estimating the soil loss. So it gives us average annual soil loss. It also helps in determining the adequacy of conservation measures. The USLE developed by Wischmeier and Meyer, and the same was published in the year 1973 by Wischmeier and Meyer. The USLE is an erosion prediction model for estimating long-term averages of soil erosion from sheet and rill erosion from a specified land under a specified condition. The term universal refers consideration of all possible factors affecting the soil erosion or soil loss, and also its general applicability. The equation A equal to RKLSCP used. Just remember these terms RKLS, they are taken kept together, and CP. So these are the equation which is referred to as USLE. A equals to RKLSCP. USLE is that kind of fundamental thing of soil and water conservation engineering. So it is expected that if you say to somebody that you have read this course, it is expected that you at least will know universal soil loss equation. So that is why my request will be that please do remember and do understand this universal soil loss equation. So just repeat, A equals to RKLSCP is the universal soil loss equation. Coming to different terminologies, A is the average annual soil loss and unit used to metric tons per hectare or tons per hectare. R is rainfall erosivity factor or index. Certain text used factors, certain other text index. I used both the terms rainfall erosivity index or rainfall erosivity factor. The unit is used here is million joules millimeter per hectare hour. K is the soil erodibility factor. L is the slope length factor. S is the slope gradient factor, and C is the cover or crop rotation management factor. P is the erosion control practices or soil conservation practice factor. या अभ्यासक्रमातील काही महत्त्वाचा भाग तुम्हाला समजण्यासाठी आपल्या मराठी भाषेत सांगत आहे. मातीच्या नुकसानीचा अंदाज. सार्वभौम माती नुकसानीचे समीकरण विचमेयर अँड मेयर यांनी विकसित केले आणि तेच 1973 मध्ये प्रकाशित केले. हे समीकरण माती नुकसानीच्या समीकरणात सोपे आणि उपयोगी साधन म्हणून वापरले आहे. विशिष्ट परिस्थितीत मातीच्या सरासरी नुकसानीचा अंदाज लावण्यासाठी सोपे आणि सामर्थ्यवान साधन आहे. सहज उपलब्ध मेट्रोलॉजिकल हवामान अंदाज आणि मातीच्या आकडेवरून समीकरणाशी संबंधित घटकांचा अंदाज लावला जाऊ शकतो. मातीची कमी होणारी व माती नुकसानीवर परिणाम करणारी सर्व संभाव्य घटक आणि त्याच्या सामान्य व्यवहार्यतेवर विचार करण्यासाठी युनिव्हर्सल हा शब्द आहे. So let us see these forms one by one. Let us see the first term, which is rainfall erosivity factor, which is designated by letter capital R, and rainfall erosivity refers to the intrinsic capacity of rainfall to cause soil erosion, and it is function of kinetic energy, and which express the ability of rainfall to erode the soil particles from an unprotected field. It is a numeral value. From long-term field studies, it has been observed that the extent soil loss from a barren field is directly proportional to the product of two rainfall characteristics. First one is the kinetic energy of the stroke, and second its 30-minute maximum intensity. We also saw it is the raindrop impact, which is the major factor behind the detachment process. So that is the raindrop impact which causes, so that intrinsic capacity of the rainfall to cause soil erosion. That simply means to start the detachment process, which obviously depends on the kinetic energy and intensity of rainstorm, that is referred in the terms of rainfall erosivity, and it is expressed as product of kinetic energy of the storm and the maximum 30-minute intensity of the storm. So during that particular storm we have to find 30-minute duration where the rainfall intensity is maximum. तर मग एकानंतर एक अटी पाहू. जे पर्जन्य मातीचे नुकसान करणारे आहे ते मोठ्या अक्षरात कॅपिटल आर ने दर्शवितात. पावसाच्या कमतरतेमुळे मातीची कमतरता भासण्यासंबंधी पावसाची आंतरिक क्षमता दर्शवली जाते आणि हे गतिशील ऊर्जा आणि पावसाच्या वादळाची तीव्रता यांचे कार्य करते, जे पावसाच्या असुरक्षित क्षेत्रापासून मातीच्या कणांना नष्ट करण्याची क्षमता दर्शवते. हे अंकात्मक मूल्य आहे. दीर्घकालीन शेतीच्या अभ्यासानुसार असे दिसून आले की शेतातून मातीचे नुकसान हे दोन पावसाच्या वैशिष्ट्यापैकी प्रथम एक वादळाची गतिशील ऊर्जा आणि त्याच्या 30 मिनिट जास्तीत जास्त तीव्रतेच्या प्रमाणात होते. पाण्याचे थेंब उडाल्यामुळे होणारी पाण्याची धूप आणि हे देखील पाहिले की रेनड्रॉप इम्पॅक्ट आहे, जो या प्रक्रियेमधील प्रमुख घटक आहे. त्यामुळे परिणामाची अशीच कारणे आहेत ज्यामुळे पावसाच्या अंतर्गत क्षमतेमुळे मातीची धूप होते आणि स्वतंत्रपणे प्रक्रिया सुरू होते, जी स्पष्टपणे गतिशील ऊर्जा आणि त्या वर्षाच्या तीव्रतेवर अवलंबून असते, जे त्या पावसाच्या क्षमतेच्या संदर्भात नमूद केले जाते. आणि हे वादळाच्या गतिशील ऊर्जाचे उत्पादन आणि जोरदार जास्तीत जास्त 30 मिनिट तीव्रतेचे उत्पादन म्हणून व्यक्त होते, जेणेकरून त्या विशिष्ट वादळाच्या दरम्यान पावसाची तीव्रता जास्तीत जास्त 30 मिनिटाच्या कालावधीमध्ये शोधायची असते. The next term is soil erodibility factor, that is capital K, and erodibility we have saw rainfall erosivity and now seeing soil erodibility. This factor is related to the various soil properties by virtue of which a particular soil becomes susceptible to get eroded either by water or wind. So remember, erosivity is the characteristic of the rainfall and erodibility is related to soil. So erodibility is the resistance of the soil to both detachment and transportation. So if any particular soil which can resist detachment and transportation, so obviously the erosion will be less. So that is the measure of erosion. So erodibility represents that. Physical characteristics of the soil greatly influence the rate at which different soils are eroded. In general, the soil properties such as soil permeability, infiltration rate, soil texture, size and stability of soil structure, organic content and soil depth affect the soil loss in large extent. पुढील भाग म्हणजे मातीची धूप होण्याची क्षमता. म्हणून लक्षात ठेवा, पावसाच्या पाण्यामुळे मातीची धूप होत असते. पावसाचे वैशिष्ट्य धूप होण्याशी संबंधित आहे. जर एखादी विशिष्ट माती जी ही जाड व वाहतूक वाचू शकते तर स्पष्टपणे दर्शवते की मातीची धूप होण्याची क्षमता वाढते. मातीची भौतिक वैशिष्ट्ये मोठ्या प्रमाणात नष्ट होण्याच्या दरावर मोठ्या प्रमाणात प्रभाव पाडतात. सर्वसाधारणपणे मातीची क्षमता व मातीचा पोत, आकार आणि मातीची संरचनेची स्थिरता, सेंद्रिय सामग्री आणि मातीची खोली यासारख्या मातीचे गुणधर्म मोठ्या प्रमाणात मातीच्या नुकसानास प्रभावित करतात. We come to the next factor, that is the topographic factor, and the topographic factor includes factor for slope length and slope steepness, that is LS. Taken together we write as LS. LS to be considered where L stands for slope length and S stands for slope steepness. The LS factor represents the erosive potential of particular soil with specified slope length and slope steepness. This factor basically affects the transportation of detached particles due to surface flow of rainwater, either that is overland flow or surface runoff, and accordingly affects the value of soil erosion due to any given rainfall. The capability of runoff, overland flow, detached transport and soil materials gets increased rapidly with increase in flow velocity. On steep ground surface, the runoff gets increased because of increase in runoff rate. Factors L and S are described as under. Slope length factor. The slope length is the horizontal distance from the point of origin of overland flow to the point where either the slope gradient gets decreased enough to start deposition or overland flow gets concentrated in a defined channel. Slope steepness factor. Steepness of land slope influences the soil erosion in several ways. In general, as the steepness slope increases, the soil erosion also increases because the velocity of runoff gets increased with increase in field slope, which allows more soil to detach and transport them along with surface flow. उतार, लांबी आणि चढाव घटक. मग आता आपण पुढच्या घटकावर आलो, जो टोपोग्राफिक फॅक्टर असतो. त्यामध्ये उतार, लांबी आणि चढाव घटक समाविष्ट असतात. हा घटक मुळात पावसाच्या पाण्याच्या प्रवाहामुळे मातीच्या कणांच्या वाहतुकीवर परिणाम करतो किंवा तोच एकतर प्रवाह किंवा पृष्ठभाग वाहून जातो. घटक विशिष्ट उताराची लांबी आणि उतार असलेल्या विशिष्ट मातीच्या संभाव्यतेचे प्रतिनिधित्व करते. त्या अनुषंगाने दिलेल्या पावसामुळे मातीच्या धुपातील मूल्यावर परिणाम होईल. प्रवाहासाठी मातीची सामग्री अलग ठेवण्यासाठी आणि वाहतुकीसाठी वाहून जाण्याची क्षमता प्रवाह वेगाने वाढते. जमिनीच्या पृष्ठभागावर पावसाचा दर वाढल्यामुळे पावसाचे पाणी वाढते. एल आणि एस घटक यांचे वर्णन खालीलप्रमाणे आहे. स्लोप लेंथ फॅक्टर उताराचा घटक प्रवाहाच्या उत्पत्तीच्या बिंदूपासून आडव्या अंतरावर आहे, जेथे उतार प्रवण प्रवाहाची स्थिती सुरू करण्यासाठी परिभाषिक वाहिनीमध्ये केंद्रित होते. स्टीपनेस फॅक्टर जमीन उताराचा अनेक प्रकारे मातीच्या रासावर परिणाम करतो. सर्वसाधारणपणे उंच उतारामुळे मातीची धूप वाढते, कारण शेतात उताराच्या वाढीने पाण्याचा वेग वाढतो, ज्यामुळे अधिक माती पृष्ठभाग वाहून जाण्याची शक्यता असते. कमिंग टू द soil loss estimation and then continuing with the next factor is the crop management factor, that is the C. The definition is the ratio of soil loss from a land under specific crop to the soil loss from a continuous fallow land, provided that the soil type, slope and rainfall conditions are identical. The crop and cropping practices affect the soil erosion in several ways by the various features such as kind of crop, quality of cover, root growth, water use by growing plants, etc. The last factor is soil conservation practice factor, that is the P. It may be defined as the ratio of soil loss under a given conservation practice to the soil loss from up and down the slope. The conservation practice consists of mainly the contouring, terracing and strip cropping, in which the contouring appears to be most effective practice on medium slopes ranging from 2 to 7%. आता मातीच्या नुकसानाची अंदाज येतो की आणि नंतर पुढील घटक पीक व्यवस्थापन घटक सुरू होते. विशिष्ट पिकाखाली सरळ रेषेतून मातीच्या नुकसानाचे निरंतर कोसळलेल्या जमिनीपासून मातीचे नुकसान होण्याचे प्रमाण जास्त आहे. ते निर्दोषित स्थितीत पिकातून होणाऱ्या माती नुकसानाचे घटक आहेत. पीक आणि पीक पद्धती विविध वैशिष्ट्याद्वारे मातीच्या ऱ्हासावर किंवा नुकसानीवर अनेक प्रकारे परिणाम करतात, जसे की पीक गुणवत्तेच्या प्रकारात वाढणारी वनस्पती वापरतात. सॉइल कन्झर्वेशन प्रॅक्टिस फॅक्टर मृदा संवर्धन हा घटक शेवटचा घटक आहे. उतारावरून खाली आणि खाली जमिनीच्या नुकसानास दिलेल्या संरक्षक अभ्यासानुसार माती नुकसानाची प्रमाण म्हणून परिभाषित केले जाऊ शकते. संवर्धन पद्धतीमध्ये मुख्यतः टेरेसिंग, मजगी आणि पट्ट्यावरील पिके नियंत्रित करणे समाविष्ट आहे, ज्यामध्ये मध्यम उतारावर 2 ते 60% श्रेणीतील सर्वात प्रभावी आहे. नाउ लेट अस कम टू ए प्रॉब्लेम. वी ट्राय टू सी आफ्टर सीइंग द युनिव्हर्सल सॉइल लॉस इक्वेशन, let us try to solve problem. And the problem says that giving the following data, calculate the average annual soil loss. Rainfall erosivity index 1000 meter tons per hectare. Soil erodibility index 0.20. Crop management factor 0.50. Conservation practice factor 1.0. Slope length factor 0.10. So here R is given, K value is given, C value is given and P value is given, and LS factor obviously we have L and S known. Also explain how the soil affected by soil conservation practice, so that obviously we can know the values of all the factor and thus putting in the equation and calculate. So that simply means you want to use the USLE equation for estimating soil loss from a given condition. Then we have to obviously obtain the value of all the factors RK, LS, C and P to able to apply this equation. So this is the second problem. Field is cultivated on the contour for growing maize crop. The other details regarding USLE factors are as follows. K equal to 0.40, R equal to 175 ton per acre, LS equal to 0.70, P equal to 0.55 and C equal to 0.50. Compute the values of soil loss likely to take place from the field. Also make a comment on soil loss when same field is kept under continuous pasture with 95% cover. Assume the value of factor C for new crop is 0.003. So with this we have seen USLE, that how to use universal soil loss equation, what are the factors involved in the universal soil loss equation. So stay tuned for next video practical lecture. Thank you.